Okay, so now up until now we've talked about the mapping where we have we don't have onto, right? So we have the two properties, one-to-oneness and onto. So far we've seen that if homomorphism doesn't have the restriction of being onto, it's not a big deal. It doesn't really lead to anything like too interesting, because what we did find out is that it's onto something, right? That it's always going to be onto a subset, right? So in fact, particularly its range, right? So in that regard, not very interesting. But what about the one-to-oneness? Now, if it's not one-to-one, then we can see how we might have relationships that are many-to-one, right? So instead of one-to-one, we could have many-to-one. And that brings up the idea that, if you recall, for any function that goes from one vector space V to another vector space W, that we can, if it's, for example, a many-to-one relationship, then we could say, okay, well, there's going to be what we call an inverse image, where for every vector in the codomain, right, there's going to be a set of vectors in the domain that map to it. And so that's what we call the inverse image, okay? And so we're going to talk about that more. In fact, in this example here, example 3, let's consider the projection pi from R3 to R2. So here we're going from a plane, right? The plane we're projecting down to a line, right? So this is our projection pi. So now this is a homomorphism that is a many-to-one relationship, right? You're going from a plane to a line, right? So now, in this case here, there's an inverse image set that is a vertical line of vectors. Because if you go inverse, if you start here, right, a point in the plane, right, or a vector in the plane, you're going to hit, and you're going here. The only thing that's different is you're adding a z vector, right? So you're adding something like this. So if you have the, oops, let me do a better job. So if we do something like that, right? And so here's z, right? So here's x, y, and z. So we might have an inverse image that basically is a vertical line of vectors. That originate from 0, and it just keeps going up on the z-axis, okay? So one example of showing an inverse image is to look at this, where we have 1, 3, and we go to 1, 3, z, where z is a real number. So we're starting at 1, 3. So for example, let's say this is, let's erase this for a second. Okay, and so let's say we're 1, and we're at 3 here. And so we're saying right about here on this plane is a dot, and we're going up in the z direction. And so we're going to have vectors that are going along that line, okay? And so that would be the inverse image, right? The set of all vectors that are along that z, okay? So, okay, so that's all I want to say about that. Have a great day.